Hello, everyone. I'm Sergei Egorov from Zero Turnaround. I'm going to talk about test containers. And thanks for coming. So, just a quick question. Who is doing integration testing already? Whoa, great. So, you probably know what I'm going to present as abstract part. Still, would like to mention that integration testing is a reality check. So you check how your application will behave in a real environment without actually having a real environment. But it's not like a unit testing where you mock everything, where you test the code. You actually test your application. And I think it's a great part about it. So what's really important for integration testing is isolation. So you don't really want your test to fail because of a third-party component. For instance, you test your microservices, and you test your first microservice, second one fails, and you don't really know why your application is failing. So when you test, when you perform integration testing, you test real databases, real network and file system. So it's not like unit testing where, OK, I'll just mock out this bin and that one, and I'll respond with this specific answer to this call. No, it's not. You test that your application will execute the queries you wrote, and the result of these queries will return proper result for your service call. But it's gray box testing. So it's not a black box. You still know some details, something about your application. You know how you query, but you use public APIs to query your application. And let's start with analogy. Like, it's easier to explain on some simpler things sometimes, but I will explain on electronics. For instance, we develop a microchip. OK, let's think about unit testing as simulation. So, OK, I'm an electronics engineer, and I design my microchip in my program. So I see some visualization of the process, and I see that it behaves fine in my Proteus, for instance. So I think that everything is fine. Because I got a good response in simulation. But now, then I have to perform integration testing. So I actually built a microchip, a single one, not a bunch of them, not a commercial part, but just one. Then I use prototyping board, and I put this single microchip on this prototyping board. And I create some real resistors or some other components. So you don't put all your components to this prototyping board. It's just a single one. And you connect power bus. You check how electricity passes through your microchip. But only single one. And now it's system testing time. So we order a test board. Maybe we order it, I know, from China. We wait. So it's time wasting until it arrives. And then we check that power we apply it to our board is enough to make it work. Because sometimes, OK, you assume that your microchip will consume 5 volts, and it will work. You don't really think about how many chips will be on this board. Kind of the same with your microservices. So you think about your own microservice, and you don't really care how it will be deployed somewhere on staging, for instance. But eventually, your staging environment might consume a lot of CPU. So your service will be slow, for instance. and some circuit breaker will stop queries to your service. Kind of the same here. Plus some interference between the components means that single component in integration testing might work. But when there is one more component next to your component, it might break it. So I'm not saying that integration testing will solve all your testing issues. No, you should always test your system as well. But right now, I'm going to talk only about integration testing. Plus, don't forget that even if you covered your application and you have unit testing, it's all green. Integration testing is green. System testing is green. Don't forget about the production. Because sometimes you ship. And when you ship, sometimes, well, it just explodes. So, speaking about integration testing, definitely a good thing about it that you test it in the real-world environment, as I said. So you don't make any assumptions. You test your queries. You're not testing string of this query. You test how this query will be executed in the real database. Plus, you can run integration testing in development environment, I mean, during the development. So it's not like, OK, unit tests are green, push, and now fix broken build. No, you can run integration testing and verify that with database, your code will be executed the same as you thought it will be. But the same good thing is a bad thing or hard thing about integration testing, that you have to start these real databases, and sometimes it's not that easy because developers work on Windows, Mac, Linux, and you should support all these environments, and it's not that easy sometimes. And of course, it's slower than unit testing, because in unit testing, you can just create an object, you test, object of your class, for instance. But in integration testing, you have to start your application. You have to wait until it started. You have to wait until Spring context is created. And unfortunately, in Spring 5, there will be no parallel resolve of beans. He's looking at his phone. Yeah, so no parallel resolve of beans in Spring 5. It means that it takes some time to start your context. So it's slower. And also some corner cases, it's just too hard to cover them. So unit testing is still there, but don't forget about integration testing as well. So obvious solution to solve this is Docker. So Docker is growing, and it's proven to be a great solution to start integration testing environments. So with Docker, you can start a bunch of databases, some MySQL, Redis, Couchbase. You can start some other components of your system if you want, and with just a single requirement, Docker. So I think it's great. At abstraction level, you talk with Docker as an abstraction to start your dependencies, your real dependencies, not code dependencies. And it's CI friendly, so if you have some environment you use to test during the development, you can actually reuse the same environment on Jenkins, for instance. So you start exactly the same environment. And for instance, our legacy testing infrastructure in zero turnaround, and we test a lot. We run, I know, almost million, we start almost million application servers per night in zero turnaround. And in our legacy infrastructure, testing infrastructure, we have to install all these databases, all these application servers manually with Chef. So imagine amount of pain to maintain this cluster. It's really hard. But with Docker, it's just, OK, dear services and operations guy, please make sure Docker is installed, and we'll run the rest. It's really friendly. Plus, it's cross-platform, so Docker can be run on Linux, Windows, and Mac with some limitations, okay, but we can solve them. So I think I can say that it's cross-platform. And of course, Docker Compose, it's such a great tool to decoratively describe your environment. So you can commit it. You can send a pull request like, we are upgrading to Postgres 9.6. So I'm updating this Compose file. So it's not like it used to be. On my previous jobs, when I was introduced to our projects, it was like, please read this 3 screens wiki page, how to install all our dependencies. So you have to install MySQL. If it fails, please use this link. If it's not, use that link, and so on and so forth. So I think everybody knows how painful might be to reproduce all your service dependencies during the development. And of course, Docker Compose is a great tool to handle it. But first of all, Docker Compose, if you want to define it separately, you have to hard code the ports. So as you can see, I have to hard code, for instance, this Redis port, because my application expects Redis on port 63789. So I have to deal with port conflicts. For instance, I have microservices. One microservice uses Redis and MySQL, another one Redis and Postgres, for instance, or Hazelcast, but it doesn't matter. And if I'm trying to start both services, I will get conflict because Redis is already started and this port allocated. And of course, I can't share one huge file of all our dependencies because I don't really want to start all of them. And if you are not on Linux, it means that you will constantly deal with Docker environment. So Docker PS, Docker is not found. Oh Jesus, Docker env. Oh Jesus, copy paste Docker env, paste it. Yay! Finally, Docker is there. Now I go to IntelliJ, I do something with Docker, and it's not working. Why? Because IntelliJ started from another terminal session, for instance, and there are no Docker env environment variables. Not true for Docker for Mac and Windows, but it's not really there yet, so we still have to talk about Docker machine. Plus, of course, there is no place like localhost except Docker machine. So you read about Docker, it says, run Docker run nginx port 80 and open your localhost so you will see your container running. You execute this command, nothing happens. It's not mapped. Why? Because you're using Mac, and it means that you have to use another IP, like Docker machine IP. And in boot to Docker, it was static. In Docker machine, it's dynamic. So you have to remap ports. You have to do some port forwarding if you want to get them on localhost. I wrote tool called forward to Docker. It's a tool to automatically forward them. It works nice, but you have to constantly run it to remap them. Not a really good experience. Question, can we improve that? Okay, we agreed to use Docker, but how we can improve that? No, Johnny, no, we will not remove anything anymore. So we will use test containers. What is test containers under the hood? So it's as simple as these 3 lines. That's it. So, okay, I want Postgres container. I just start Postgres container. And it will handle the rest. So it will connect to Docker, it will start it, and so on and so forth. So I use declarative syntax to define my dependencies, my database dependencies, for instance. I think this is huge. It's a huge step for integration testing. It never used to be like that. I remember something with Vagrant to do something similar, but it wasn't as easy as test containers. And of course, it's open source project started by Richard, and we in Zero Turnaround, when we discovered test containers, we decided to merge actually our internal Docker test engine with test containers. So we joined our forces, and we took all good parts from both products, because ours was closed sourced inside our company, but we decided just to open source it and merge both projects. So right now it's a single project supported by Zero Turnaround as well. And as I said, it's just declarative Docker Java API wrapper. So it's not a new thing. You just use Docker, you call Docker from your Java application, from your tests. And it reuses Docker Java library as open sourced as well, developed by third parties. So we don't do any Docker connection stuff, actually. We just wrap it. We're making it easy to use. And basically, it used to be JUnit only, but we are moving forward to other test frameworks. So right now, you can use it with TestNG, Cucumber. Cucumber, does anyone know what is Cucumber? Yeah, you wrote a Selenite example for Cucumber. Yeah, so good. So yeah, it's not only JUnit. And how it works? Of course, it's Docker Java under the hood. Great part about test containers. Some dude from the internet asked us to extract our Docker environment discovery as a separate project because it's so good, it's so useful. It handles a lot of boilerplate and a lot of hard things about Docker environment. So if you use Docker machine, it will start Docker machine for you. So you don't have to start it. It will also configure Docker environment for you. So you don't have to run this Docker and nothing. You just install Docker on your machine, and test containers will handle the rest. Docker for Mac is supported as well. I use it with Docker for Mac, and right now Docker for Mac, I'm not sure if it's released or not. I mean, it's publicly available, yes, but I wouldn't say it's release stage quality. Anyway, another thing about running Docker for testing, you don't have to stop containers yourself. So test containers will do it for you. So you just define your containers, you run your tests, it will start containers, it will drop containers. So no need to handle the life cycle, it's handled for you. You can stop them during the runtime, or you can just do some throwaway containers, it doesn't matter. So I will show you a few demos of test containers, and the first one will be, I know, my favorite one. So how many of you use Spring Boot? Spring Boot, whoa, it's so popular, especially according to our Rebel Labs report. So yeah, Spring Boot, awesome. So we will use Spring Boot REST service, and of course it's in Java, not in .NET yet. Also, we will depend on Redis and Postgres. So back in the days, I wrote Maven plugin to start Redis fake server, and it's pretty popular actually, because I really like Redis. It's amazing software piece, so I really like it, and it's great. But it's native dependency, it's not in Java, so I can't just start it from my own code. I have to start it as binary. So the same with Postgres, plus configuring Postgres might not be that easy to do. Plus, we will call some other microservices, because you know it's Go buzzword microservice, so why not demo it as well? So yay for microservices. Okay, I had to restart my computer. But while IntelliJ is starting, it will take half of my talk. Oh no. Okay. Start. Starting. Okay, let's wait. We wait. It's supposed to be faster, but it's not. Anyway, it takes some time. To start. Now it started. Okay, Docker PS. Oh no. My favorite. Oh yeah. Oh, now it started. So Docker PS. Okay, Docker PS again. Nothing, as you can see. So no Postgres, no Redis. So no. Okay, I got tired. Let's just stop it. Screw it. And let's open our first demo. Let's just submit it from scratch. Okay, wait until it stopped. Okay, and I have pretty simple Spring Boot application with the only controller. And here I call Geo service with Feign. So I use some Spring Cloud stuff here. I think that extracting Geo service is really nice infrastructure. So I just decided to create a separate deliverable thing for Geo service only. So for each conference search, I run Geo service to determine the city for the given coordinates. And then looking for conferences by this city ID, and I answer with the conferences I have. So conferences repository is simple Spring JPA, Spring Data JPA, and also I cache response from Geo service because when I just deployed it first, I saw some huge latencies because each new call consumed me 100 milliseconds. So yeah, I cache, and I cache it in Redis. So let's open my test. Is it big enough, or I should increase? Okay, so these numbers are Tallinn's coordinates, at least according to Google Maps. And what I'm going to do, I will test that cache works. So for each city request on my microservice, I will respond only once. So I configure my mocking server. I will explain it, what is it later. I will answer only once. So in this scenario, second call shouldn't call city service again. So it should be cached, given the same arguments. Plus, I'm checking that simple search returns these three conferences known to me. Why? Because I configured data.sql file. So Spring is a really nice feature. Spring will fill the database with some data. So it's real insert query. Data will be there in Postgres. Let's verify that Docker is not running. Nope. Stopped. You see it? It stopped. Believe me, it stopped. So let's run our simple JUnit test. It builds and it runs. Let's focus on this part. You see, TestContainer managed to find Docker machine. So now it attempts to start default machine for you. So you don't have to. It's really useful. Okay, as you saw, it takes some time to start the machine first, but this is something you're not going to do every test run. You just start it if you haven't started it yet, and it started. Awesome. Now, as you can see, Redis, and Postgres, as well as mock server, already started. So, yay, Spring banner, great ASCII art, by the way. So, let's run it again without waiting for Docker machine, because Docker machine is the slowest part of how this demo. We run it, and it started, container started, Postgres takes some time to start, but we can't do anything with it. Somebody contributes some cool default settings for Postgres, so it will start faster. And yeah, that's it. By the way, as you can see, for some reason, IntelliJ counts only test execution time, not test preparation time. So it's not clear to show these numbers as test execution time. But test itself was executed in less than 2 seconds. And the cool part, that second test was reusing already started containers. So we already started Postgres, Redis, and stuff. So why not to reuse them? Just make sure that it's clean. So first one took 1.5 seconds. Another one was much faster, like 261. So yes, it's slower than unit testing, but it's not that slow. If we talk about testing the whole application, come on, it started 3 databases, okay, 2 databases and 1 dependency. And Spring context was started. And that's it, just in 2 seconds plus overhead of initializing of containers, which takes, 4 seconds. Let's review how I implemented it. So what we have here, the same code from my previous slide. So we have Postgres container, as you can see, without any additional configuration, but we don't have Redis container. So we support some databases in TestContainers, like Postgres, MySQL, few others, but not Redis. But it's not a problem. I can use any Docker image available on the net. So I'll use Redis from Docker Hub to start Redis. And I expose Redis port. It means that I want Redis port 6379 to be mapped at random port on my machine automatically, or not on my machine, on Docker machine. Plus I start mock server container. I will show it later. Plus I use Spring initializer to set these properties to Spring. So I set them exactly the same I do in my production environment. So I set Spring.source URL to data source URL from my RDS. I do the same. So I just do, let's focus on this part. I do PostgreSQL get JDBC URL, that's it. So it's real JDBC URL, the same you do in production. Plus I use Feign in my application and Spring Cloud infrastructure. So I have to tell Ribbon where to get my servers. So for this Java service, I hard code this single server, mock server I started. So mock server is a Java application to answer with some network mocks. It doesn't matter, JSON or any other response. So the same you do in unit testing, like use Mockito just to make some, just to mock some calls. You do the same, but you stub. You step them at the network level. So for this network request, respond with this value. So it's real testing. It's the way how your other microservices in system testing, for instance, or on your production will respond. And as I said, mock server, a special container I created myself locally. So I have this as part of my test case. I was reusing this mock server container across my tests, so I decided to extract it. So creating new containers is as simple as this. You just extend from generic container, the same we do in Postgres container, for instance. And then you say, okay, I want this image, I want this port. Plus, mock server provides really nice Java client. So when containers started, and TestContainers does really nice job at life cycle. Once containers started, I create mock server client. As simple as that. So yes. Second use case, special one. Well, Selenium is great, Selenite is great as well, but you have to deal with environment configuration, like you have to install this Chrome driver, Firefox, and other things to make them run. So what I did, I just cloned Selenite Cucumber example. I'm really mad about cucumbers, so don't blame me. It's really great thing for testing. So I know about Cucumber. I know that in Cucumber I can run a hook before I start my scenario. So what will happen if I will run this clone and run example of Selenite? I know who did it. I think, yeah. So it fails. Why? Cannot find Firefox binary in path. What? I'm on Mac. I don't know anything about binaries. You know, I have just .app, or I have moved this to applications folder. I don't know about binaries. Come on. It's so old school. Okay, so let's replace it with test container, because test container can run Selenium inside Docker as well. How cool is that? You know, you can run Chrome inside, I know, inside Docker. So I will create browser WebDriver container equals new browser WebDriver container with desired capabilities from Selenium. Actually, it's not test containers. So before Cucumber API Java, it's not JUnit. Void before scenario. Now let's check if WebDriver runner has WebDriver started. If not, then WebDriver container start. So in JUnit, start will be called by JUnit rule, because it's JUnit rule. But here we don't have any JUnit. Okay, we do, but I will not execute any JUnit here. I will use IntelliJ run, so all features in Cucumber, no JUnit. And then I will just do WebDriver set WebDriver container, get WebDriver. That's it, as simple as that. Let's run it again. And boom, it's green. So how many? 10 lines, you know? Now we can run this example anywhere, like anywhere where you have Docker, including Jenkins. So how it was before. Hey guys, we need one more node with Chrome installed. Hey, it's installed, but it's not in path. Hey, it's wrong Chrome version. And by the way, speaking about versions, test containers will detect Selenium API version and will choose proper Selenium image from Docker Hub, because it's one-to-one mapping. For each Selenium version, Selenium Java driver, you have Docker image. So it's dynamically, it will dynamically choose. It's really cool. By the way, when I said that it works with Docker for Mac, let's test it. Let's just stop our Docker machine. As you can see, I'm starting my Docker for Mac. Actually, I don't really like Docker machines, so let's just remove default. Yeah, I am. Believe me, I am. Okay, now we have Docker. Awesome. Oh, no Docker env. Let's run it again. Looking for Docker environment, accessing Docker for Mac, Unix domain socket. So as you can see, it actually works with Docker for Mac as well. And it will record video of your Docker container with Chrome, so you can check the video. So it's not like a black box browser running somewhere. You can watch the video with VNC recorder later. And the last case, the case why we, as Zero Turnaround, decided to use test containers, because we have to test our Java agents. So what does it mean to test Java agent? It means that you have to start new JVM. new specific JVM like 6, 7, 8, 5, 4. Anyway, you have to attach Java agent to this JVM. So it's not that easy as you can think. Our previous testing agent was, I know, damn a lot lines of code just to start this JVM and databases. So I have this simple Java agent. Everyone can do that. It's I know, hello world from Java agents world. So for each jetty handler, I will set header x my super header to header value, right? Right. So I have a test application. In zero round, we use Groovy to write these test applications. So it's as simple as that. So we use Spark Java, as well as Spring Boot, JAX-RX, Grizzly-based applications. But in this case, I will use Spark Java because it's just 3 lines of code. Like, you know, it's just grab, and then you can write something like, oh, geez, post WE request response, and I can test my post integration, or I can call, for instance, Redis from this script. So it's really cool. And in my agent test, I will just verify that for each request I do, I get x my super header, and the value is equals to header value. And as you can see, first of all, it's really fast. So it's like 8 seconds or something like that. And actually, it works. And speaking of test applications, we wrap our scripts in containers. Of course, so we run them inside Docker. We attach some I/O sources like Redis, all the things. So yeah, here we say that, okay, this test application extends Groovy test application, and it will use app.groovy. Plus, it will wait until application responds to /hello. So what is it? It's health check. So your container will not be treated as started until it responds with 200 to /hello. It's really nice. So you can wait, I know, 5 minutes until your application starts, for instance, until you start making your requests. And we use feign to map our test requests. So it's declarative way, really recommended. And Groovy test application is simple as well. So unfortunately, Groovy is not on Docker Hub yet. And we use our own image, like zero-round/Groovy. Doesn't matter. You can use any image you want. You can use Java, clean Java, and you can map your test applications like war or ER. Doesn't matter. Plus, we map our agent inside of this container as well as application, and we cache grapes. You saw this add grab Spark Java. It will download Spark Java from Maven Central. So to cache this, we use file system cache. It's built-in feature by Groovy. And we attach Java agent, but we can write any Java option we want here. So if our Java agent wants some property to be set before we start, we can just write this here, QWE123. That's it. And we can throw the command. So it's up to you how to run it. In our case, we decided to use it like this. Plus, if somehow I did a mistake, so for instance, yeah, this was my mistake. I know, Gleb, if you do some Java agents, then you know this issue. Okay, I forgot to append loader class path, and it means that JavaSys will fail to instrument this code. So you can see, test failed, and I see standard output right in my test. So on Jenkins, it will be test aggregator from Jenkins, no special file grabbing. And I see that, okay, cannot compile, cannot find Java in string. What? Anyway, I spent 1 hour debugging it. So yeah, this is how we do it. And this simple project, available on GitHub. We'll share later on Twitter, so follow me on Twitter. Helps you to test and develop Java agents. As you can see, I just applied the change and run test again and got this failure. So it's development cycle of Java agents never was that fast, really. Okay, I guess that's it. I don't have a time as well, so quick questions. Whoa, cool. Okay, everyone understood everything? Awesome. Yeah, no questions means, yeah, everyone understand or nobody does. Yeah, thank you.